This lesson explains the meaning of rational exponents. In previous lessons, you learned about exponential expressions and powers. By definition, the nth power of b is n factors of b. For example, the second power of 5 is 2 factors of 5. So we can say 25 is the second power of 5 because 2 factors of 5 are equal to 25. And 27 is the third power of 3 because 3 factors of 3 are equal to 27. And 16 is the fourth power of 2 because 4 factors of 2 are equal to 16. In previous lessons, you also learned about radical expressions and roots. By definition, a is the nth root of b if n factors of a are equal to b. For example, 5 is the second root of 25 because 2 factors of 5 are equal to 25. For a radical expression, this is the radical sign. The expression under the radical sign is the radicand, and this small number is the index. The index gives the degree of the root. So we can say 5 is the second root of 25 because 2 factors of 5 are equal to 25. And 3 is the third root of 27 because 3 factors of 3 are equal to 27. And 2 is the fourth root of 16 because 4 factors of 2 are equal to 16. Also, second roots are often called square roots, and third roots are often called cube roots. Finally, sometimes you might see a radical without an index. In this case, you can assume the index is 2. Now, it turns out there's another way to represent roots, a way to represent roots without the radical sign. That's with rational exponents. Exponents that are fractions. By definition, b to the power of 1 over n is the same as the nth root of b. The denominator of a rational exponent is the index or degree of the root. So 25 to the power of 1/2 is the same as the second root or square root of 25. And 27 to the power of 1/3 is the same as the third root or cube root of 27. And 16 to the power of 1/4 is the same as the fourth root of 16. If you look at these expressions more closely, you'll see this notation makes sense. For the expression 25 to the 1/2, rewrite 25 as 5 squared. Then you have a power of a power, so multiply the exponents for 5 to the 2 over 2, which is 5 to the 1, which is 5. So you can see 25 to the power of 1/2 is equal to 5. Also, for 27 to the 1/3, rewrite 27 as 3 to the 3. Then multiply the exponents for 3 to the power of 3 over 3, which is 3 to the 1. So 27 to the 1 over 3 power is equal to 3. Finally, for 16 to the 1/4, rewrite 16 as 2 to the 4. Then multiply the exponents for 2 to the 4 over 4, which is 2 to the 1. And so 16 to the power of 1 over 4 is equal to 2. So you can see rational exponents as roots make sense. Returning to the definition, if you add a numerator to the rational exponent, you can express a power and a root in the same expression. For example, the expression 16 to the power of 3 over 2 is equal to the square root of 16 to the third power. Since the square root of 16 is 4, the expression is equal to 4 to the 3, which is 64. The order in which you calculate the root and power don't matter. For the same expression, you can calculate the power and then the root, and you get the same value, 64. There's much more to learn about roots, radicals, and rational exponents. For now, there are 3 things you need to know how to do. For the first example, to find the 4th root of 81, you need to find 4 equal factors of 81, which is 3. So the 4th root of 81 is 3. For the second example, to find the 3rd root of 216, you need to find 3 equal factors of 216, which is 6. So the 3rd root of 216 is 6. You also need to be able to convert an expression to radical form. For the first example, the rational exponent applies only to the variable, so it's 6 times the 5th root of a squared. For the second example, because of the parentheses, the rational exponent applies to both factors, so you have the 3rd root of 5m. Here's an example that's a little more interesting. Rewrite the radicand 54x as 27 times 2x. Then apply the exponent 2 over 3 to both factors. Next, rewrite 27 as 3 to the 3. Then multiply the exponents for 3 to the 6 over 3, which is 3 to the 2, and you have 9 times the 3rd root of 2x squared. Finally, square 2x, and the expression in radical form is 9 times the 3rd root of 4x squared. Finally, you need to be able to convert an expression to exponential form. For the first example, remember, the root is the denominator and the power is the numerator. So it's b to the power of 3 over 5, the 3rd power of the 5th root of b. For the second example, the exponent applies to both factors in the radicand, so it's 5m to the power of 1 over 3. For the third example, the exponent applies only to the variable, so it's 2 times w to the 1/2. For this example, rewrite the root as a rational exponent 16, a to the 3 to the power of 1 over 4. Then apply the exponent to both factors. Next, rewrite 16 as 2 to the 4. Then multiply the exponents for 2 to the 4 over 4 times a to the 3 over 4. Next, 2 to the 4 over 4 is 2 to the 1. And the expression in exponential form is 2 times a to the 3 over 4. This lesson explained the meaning of rational exponents. And this lesson was brought to you by the Math Fun Academy. Its continuing mission: to explore strange new worlds, to seek out new math and new equations, to boldly go where no math student has gone before.